going to create a simple circuit, the circuit for a light bulb. I have my battery. This is the symbol in the future for batteries. And this is the positive terminal, and this is the negative terminal. No, guys? Okay. And I am going to use for positive cables, what color? Red, red. And negative? Black, the return. No? Okay. Okay, I start here. And what is the first element that you found in the circuit, in a typical circuit?
Fuse.
The fuse, the protection, the fuse. Okay, now I am going to explain what is the process to calculate the capacity of the fuse. That's the fuse. After the fuse, you found that what?
Switch.
The switch or interrupter to open and close the circuit. Okay, the switch. And after that, you found
The load.
the load. For example, I am going to, this is a light bulb. No? And this is the positive terminal, the positive terminal. My positive will be connected here. And what about in the case of the light bulb? That's the negative. That's the negative. That's the return. And the return finish into the negative of the battery. This is a circuit. Nice, no? I am going to create two types of circuits. Series circuits and parallel circuits. You remember when you connect the batteries in parallel and when you connect the batteries in series in the previous laboratory with Danny? What happened when you connect the batteries in parallel? What element stay constant?
The voltage.
The voltage. No? You can connect 6 batteries in parallel and the voltage is 12, 12, 12, 12, 12. Because it's in parallel. But in parallel, what happened with the intensity?
Stays the same.
If I have each battery 100 amps and I connect 6 batteries in parallel, the voltage is constant.
Right. Oh, it changes.
But the intensity?
600.
600, no? 100 plus 100, 600. Oh, wow, the intensity increased. Oh, that's very important. Now in series, I connect 3 batteries in series, 12 volts, 100 amps each battery.
The volts go up.
The voltage, at the end, I have 36. What happened? The intensity
It's consistent.
is constant in series. Ah, okay. Let me try to connect other light bulb in series with this. You remember when you connect the batteries in series, what is the procedure? I have the first one, positive terminal here and negative. What about the second one?
It goes to a positive.
Oh, the negative of this connected with the positive of the other one. No? Ah, okay. The positive of this connected with
Negative.
the negative of this. Yes or not? We are going to do like this. The negative of this connected with
Positive.
the positive of this, and then from the negative I return, and now it's series. You like it? Ah, what happened when I have circuits in series? Ah, in series the total voltage is series, yeah, pam pam pam, increase. What happened with the intensity in series? What happened with the resistance in series?
That's out.
I added. Good? Let me try to do another circuit parallel. This is series. Don't forget, the key is what element is constant. In series is constant intensity. And now we are going to check another circuit. In this circuit we are going to connect exactly the same, the fuse, and we are going to connect the switch, and after the switch we are going to connect 2 light bulbs or 3 light bulbs in parallel. Okay, this is the situation. I am going to connect the positive of those 3 light bulbs, and after that the negatives together, and I return from the negative here in this. This is
Parallel.
parallel, and this is series. What happened here in parallel with the total voltage in parallel? The voltage of this is
Equal.
pam 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 pam. Doesn't matter how many I connect in parallel. What about the intensity here in parallel? The intensity? Now the tricky. What about the resistance here in parallel? 1 divided by the total resistor is equal 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Pam, 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 pam. I'm going to demonstrate what happened with the resistance in parallel. Let me explain something, my friends. What do you think is more common, a parallel circuit or a series circuit?
Series.
Give me example of a series circuit. The Christmas light, no? What happens if one of the lights in the middle of the is broken?
They all go out.
It's broken on the garbage because it's impossible to find which one is broken, no? It's in series. Pay attention. What happens if I have this line, this group of lights in series? And what happens if this one in the middle is broken? The entire line is
Oh.
off. That's not good. What happens if I connect 3 lights in parallel and the light of the middle is broken? For example, look, what happens if this one is broken? I have 2 lights working. What happens if the other one is broken? I have another one working. Parallel. Parallel is good. It's clear the difference between series and parallel? In some cases it's necessary a series. The series connections are excellent, for example, in the harness of the engine. The majority of the sensors are connected and the switches in series. If one of those switches is open or activated, what happens? The motor
Alarms go off.
shoot down. No? Later in the classes of gasoline and diesel, we are going to check how you install those sensors. It's in series. This is why when you extend the harness of the engine, it's a lot of sensors in series. For safety, if one of those is broken, what happened with the engine? Shut down, and immediately you have the check engine light activated. Oxygen. Good?